So first I want to go over, we spoke and I showed you a video the last day of when we had two waves in water being sent out at exactly the same time in phase. They started at the same time. There was a disturbance here and a disturbance here. If you remember, the guy was poking something into the water, and they basically emitted waves. Now, when I draw waves, what would like you to understand that the line that I'm drawing is representing the peak of the wave as the wave comes out from the source. So in other words, this is a peak, a trough, a peak, a trough, a peak. Okay? So these lines represent peaks of waves as, and again, if you think about it as an entire circle of a peak, like that. Okay, they're the waves as they come out. It's the easiest way to represent waves. Okay. So now, if we look as the wave emanates out from that source, these being the peaks. Now let's look at it. Same frequency of wave is emanating out from that source also. Okay? Now, mine won't be very accurate, the drawing, but it's just to get the idea of what this means, because you can be asked in an exam. These are the two sources, coherent sources, meaning that they are in phase and of the same frequency. So they're an effectively wavelength as well. So, even though that doesn't look great, but anyway. Now, everywhere that two lines overlap, that means that you have the peak of one wave and the peak of another wave that are occurring at the same time. When you have two peaks occurring at the same time, the waves add, the amplitudes at any particular time add, and the resulting wave is therefore a larger wave. Okay? So everywhere we see the two lines overlapping, we are getting interference. This is known as interference, and it is constructive interference because the waveforms are both peaks, so when you add them, you get a bigger peak. Okay, so everywhere you see the overlap of two lines, you're getting constructive interference. Now, what about destructive interference? Destructive interference will be when you get, if you look at, this is a peak and a peak of one wave, and let's just take a peak of another wave. When the two peaks overlap, you're getting constructive interference, but in here, you have the peak of one wave, and if you think about it, between two peaks of a wave, so if we have a wave emanating out, then between, if that's a peak and that's a peak of that wave, in the middle is a trough. Okay, so when there is no line, you have, the middle between two peaks is a trough. So if we take the place where you have the peak of one wave, okay, because it's a straight line, it's on a line, so the peak of this wave, but because you're midway between the two peaks of the other wave, you are, a peak of one is meeting a trough of the other. Okay, so let's see the places where peaks and troughs are meeting. Now, this place here is not where a peak and a trough are meeting, because you are in the middle of one wave and you are in the middle of another, of the peaks of another. So here is where trough meets trough. But where does peak meet trough? Here. You have the peak of this wave meeting the trough of the other wave. Peak meets trough, peak meets trough. All of these places are where the peak of one wave is meeting with the trough of another wave. Okay? We put a few more of these. So that's that wave. A few more of them coming out here. So again, we have peak meets trough. We have peak meets trough. Again, these are peak meets peak. Okay, peak meets trough. peak meets trough. Okay. Now, if you were to walk, or sorry, well, if you were to just look along this line, you can see that you have a peak meeting a peak, constructive interference, destructive interference. Destructive is where you get a peak meeting with a trough, so when you add them together, you get effectively no disturbance. No disturbance at all. Okay? So, everywhere there's an X, there's a region of no disturbance. The water is flat if it's water we're talking about. Everywhere there's a dot, the water is particularly high. The ripple is high. As you move across, you can see that you're getting constructive interference, peak, destructive interference, constructive interference, destructive being no disturbance, constructive, destructive, constructive, destructive, constructive. Now, if I drew this properly, you would see a proper line. So if you walked along the line, you'd see constructive, destructive, constructive, destructive as you walked along. And we saw that in the pattern with the water, which I'm happy to show you the video of again on Monday. If you also were to think about this as sound waves as opposed to water, okay, again, in terms of sound waves, if these are two sources emitting the same sound at the same frequency and in phase, then if a person was to walk across here, these are the sound waves emanating out. If a person was to walk across here, they would hear, when there's constructive interference, they'll hear quite a loud sound. When there's destructive, pretty much nothing. Loud, pretty much nothing. Loud, nothing. So as a person walks from A to B, they will hear the sound varying from being loud to being very quiet. Loud, quiet, loud, quiet. And that actually is used as an experiment to show that sound is a wave because it undergoes interference, both constructive and destructive. Okay? Similarly, if we instead made this, if we generated, if we had two slits here, okay, and going through those slits, we ensured that we had light that was coherent, and in this situation we'll say that has one wave, one frequency, so light of one frequency, just yellow light, because remember every colour of light is associated with a different frequency. So if we just take light going through here, and this experiment was carried out by Young, and the way you can generate two coherent sources of light is to actually have one slit here, shine your light in here, and you get diffraction around the slit. The light gets diffracted and moves out, spreads out, and basically will enter, if I've drawn it properly, it'll enter both of these at the same time, and you will get two sources of light coming through these slits. Now, you get the same interference pattern as you do with sound, or at least it was discovered that you did, because when a screen was put up from A to B, it was noted that instead of getting just straight line, a light here and a light here, you actually ended up getting periods of light, dark, light, dark, light, dark, light, dark along the screen. And the only way that that could be explained was that light must be a wave, and the light entering through both slits interferes with each other. They interfere with each other, creating this interference pattern on the screen. Okay?